Hi everyone, these are notes 2.1 which are on equivalent ratios, and the first thing we want to do is define what a ratio is. And a ratio is just a comparison between quantities of items. And I'm going to show you an example of a ratio that you might see. So let's say someone just posted something on social media, and after a few minutes they got 100 likes, and I'm going to color code this with one color, and 5 shares. Okay, we can write the ratio of likes to shares in 3 different ways. So because it says we have to do the ratio of likes to shares, we have to put the number of likes first, and we have to put the number of shares second. So here we would just say that it is 100, and then the symbol for a ratio is a colon. That's one way we could write it. So it's 100 to 5. So these are likes to shares. And another way that we could write this is we could literally write out the word 2. So it's 100 to 5, or we could write it as a fraction. So we could say 100 over 5. And it doesn't matter, any one of these ways that you want to write it out is perfectly acceptable. Now, one quick thing that I want to show you though is that we could reduce this, because I can divide both of these numbers here by 5. They're both divisible by 5. So when I divide 100 by 5, I end up getting 20. And when I divide 5 by 5, I end up getting 1. And all that this is saying is that for every share, for every one share, there are 20 likes. So every time somebody shares the post, typically that post would get 20 likes. Now that's not always the case. This is just giving you an example of what it looks like, okay? So we could also say it's 20 to 1. Or we could also say for every 20 likes, there is 1 share. Okay, it doesn't matter which way you say it, as long as you say that the likes are the larger quantity and the shares are the smaller quantity. And then as a fraction, we could just say 20 over 1. Now, after another few minutes, the post got double the likes and double the shares. Okay, so now we're going to write the new ratio. So we're still going to do likes to shares. And so here, the number of likes here was double. So if it was originally 100 likes, now it's 200 likes. And the number of shares also doubled. So if there was originally 5 shares, now it's 10 shares. Okay, and so if I were to write this as with a word, I would say 200 to 10. And then if I were to write this as a fraction, then I could say 200 over 10. Regardless, they still all reduce to the same ratio that we had over here, because this time I can divide both numbers by 10, and I would end up getting 20. When I divide 200 by 10, I get 20. And when I divide 10 by 10, I get 1. So I would still get 20 to 1. And the reason why is because the number of likes doubled and the number of shares doubled. So we're being consistent. As long as they're both being multiplied by the same amount, they are still equivalent to each other. Okay, so this would be 20 to 1, and this would be 20 over 1. And these are all examples of equivalent ratios. So all of these ratios that we're looking at here are all equivalent to each other, because when you reduce them, they're all 20 to 1. So how do we get equivalent ratios? By multiplying or dividing each part of our ratio by the same number. So in this example here, it asks us to determine an equivalent ratio by multiplying. So our ratio is 3 to 5, and I'm allowed to multiply by any number that I want. So let's say, for example, I were to choose to multiply by 2. As long as I multiply both parts of my ratio by 2, this is allowed. So 3 times 2 is 6, 5 times 2 is 10. So this is an example of an equivalent ratio. Now, there's a lot of correct answers. In fact, there are infinite correct answers to finding equivalent ratios of 3 to 5. Okay, another example could be I could just decide to multiply by 10. And again, it doesn't matter what you multiply by, as long as you are consistent and multiplying both of these numbers by the same value. Okay, So another example that we could look at is this 6 to 7. So I could, again, multiply 6 and 7 by any number I want as long as it's the same number. So I'll multiply them both by 3. So I could say 6 times 3 is 18, 7 times 3 is 21. So 18 to 21 is an example of an equivalent ratio. I could also multiply by, I don't know, 100, for example. Again, as long as they're both multiplied by 100, it's fine. So 6 times 100 is 600, and then 7 times 100 is 700. So here's another example. Now here we want to determine an equivalent ratio by dividing this time. So I'll zoom in here so it's not as overwhelming. So here we have 8 to 10. And this time I want to find it by dividing. So what number can I divide 8 and 10 both by? Well, I can divide them both by 2. So when I divide 8 by 2, I get 4. And then when I divide 10 by 2, I get 5. So 8 to 10 is equivalent to the ratio 4 to 5. In this example, 15 to 20, both 15 and 20 are divisible by 5. So I can divide this one by 5 and this one by 5. And 15 divided by 5 is 3. And 20 divided by 5 is 4. And that works as well. And then in this example here, I have 36 to 42. And I want to see what can I divide 36 and 42 by. Well, they're both even, so I could divide them both by 2. And 36 divided by 2 is 18. 42 divided by 2 is 21. So this is an equivalent ratio, okay? And I could have a lot of correct answers. 36 to 42, they're both divisible by 3, for example. So I could divide them both by 3. And I would end up getting 12 to 14. So this is another equivalent ratio. And then I can also, in fact, divide them both by 6. So 36 divided by 6 is 6, and then 42 divided by 6 is 7. So all three of these are examples of equivalent ratios. Now, if you're not sure what to divide each one of these ratios by, you can actually use Desmos as a tool. And I don't know if any of you have used Desmos before, but Desmos is a really good tool to use. So I'm going to go right into Google and I'm going to type in Desmos scientific calculator. And here I have the scientific calculator here. And if you remember, our first ratio was 8 to 10. So I'm going to write 8 over 10 because remember we can write it as a fraction. And then if you see this button right here that I clicked on, where right underneath this arrow, it gave us 4 over 5, which is exactly what we got here. And when we do that, it'll give us the lowest reduced answer. So for example, with this 36 to 42 that we have here, 36 over 42. And then when I press this fraction button here, I get 6 over 7, which is what we got here. This was the most reduced possible answer. But 18 to 21 and 12 to 14 are also acceptable answers. Okay? Okay, so let's look at some examples where equivalent ratios are going to help us. So a recipe for pancakes uses 3 cups of flour and 2 cups of milk, and it will serve 5 people. Now we want to make pancakes for 20 people, so we want to figure out how many cups of flour and milk we will need. So our ratio, if we write out a ratio, it's going to help us out. So we're looking at cups of flour to cups of milk to the number of people right here. And so we know that we need 3 cups of flour for every 2 cups of milk, and that will serve 5 people. Okay, so we know that this is the ratio that we're going to use, and sometimes we'll have a ratio with more than 2 numbers, and that's totally fine. But we want to know what's going to happen if we were to make pancakes for 20 people. So I'm going to have a new ratio that's going to work for 20 people. So I'm going to put this 20 right here under number of people, and I'll color code this blue so we can see that it's still the number of people. So how do I go from 5 to 20? Well, I multiply by 4. And as long as I'm consistently multiplying each one of these numbers by 4, then my ratio will stay the same. So 2 also has to get multiplied by 4, and I get 8. And then 3 also has to get multiplied by 4, and I end up getting 12. And since this 12 represents flour and this 8 represents milk, sorry about that, we can say Therefore, we need 12 cups of flour and 8 cups of milk to serve 20 people. And that's our answer for this question. And that's how we would use an equivalent ratio to help us out. Okay? All right, in our next example, we have June and Megan, and they're making grape punch for a party. We know that June, it tells us June uses grape concentrate, so we'll do this purple, to ginger concentrate. Oh my gosh. So we know that June uses grape concentrate to ginger ale in a ratio of 3 to 2. Okay, and I'm color coding this on purpose. So grape concentrate, so this is saying for every 3 parts of grape concentrate, we need 2 parts of ginger ale. So every 3 cups of grape concentrate, we need 2 cups of ginger ale. Every 3 liters of grape concentrate, we would need 2 liters of ginger ale. It doesn't matter what the unit is, okay? Now, we also know that Megan uses grape concentrate and ginger ale, and I have this in using different colors because these are different ratios. So in a ratio of 8 to 5. The way Megan is doing it is for every 8 cups of ginger concentrate, she's going to put 5 cups of ginger ale or whatever unit she ends up using. Okay, so which punch has the stronger grape taste and how do you know? So for June, we know that her ratio is going to be 3 to 2. And for Megan, we know her ratio is going to be 8 to 5. And this 3 and this 8 both represent the grape concentrate. And so because I want to see which one is going to be, which one's going to have more of a grape flavor to it, I want to have my ginger ale be constant. So this ginger ale piece right here, I want it to be constant. But right now, one is 2 parts and one is 5 parts. So what I'm going to do is get a common multiple between the two. And the easiest way for me to do that, honestly, is to just multiply the 2 by this 5 and multiply the 5 by this 2. Because watch this. When I multiply 2 by 5, I get 10. And when I multiply 5 by 2, I get 10. So now I have 10 parts ginger ale for both, and now it's easier for me to compare. But if I multiply this 2 by 5 over here, then I have to multiply the 3 parts of grape juice by 5 as well. And 3 times 5 is 15. So this is saying for every 10 parts of ginger ale, I need 15 parts of grape concentrate. And here, if I multiply the 5 by 2, then I have to multiply the 8 by 2. And 8 times 2 is 16. So this is saying for every 10 parts ginger ale, I need 16 parts grape juice, which tells me that Megan's grape juice has, or Megan's grape punch has a stronger grape taste because she has 16 parts versus 15 parts. And if you have any questions, let me know and I'd be more than happy to help you out. Otherwise, that's it for this video and I'll see you next time I see you. Have a great day.